Hello guys, in this video I'm going to show you this Python package called Molmass. As the name suggests, this Python package performs molecular mass calculations. However, it does many other things that I'm going to show you during this video. So here I am in the GitHub page of the package. Okay, we have here a brief description of the package. It can calculate the molecular mass, the elemental composition, and the mass distribution spectrum of a molecule. In this video, I'm going to show you how you can do each one of these calculations. Okay, we have here the author, the license, the current version, and the DOI. Okay, obviously, the first thing you need to do is install the package. You can use pip as usual for a Python package, but if you do only pip install molmass, you will only install the core package. But this package needs some dependencies, and if you want all the dependencies to be installed, you should perform the installation as described here with this all between brackets. This way you install all the dependencies. And then dependencies are listed here. As we can see, we have here pandas as one of the dependencies. And as I'm going to show you in this video, some of these calculations can be exported as a pandas data frame. So that's why you need pandas for some features of this package. Okay. So what I'm going to do in this video is open a Jupyter Notebook and show you some examples of how you can use this Python package for some chemical calculations. Okay, so I have here a Jupyter Notebook. I'm using Jupyter Notebook inside a VS Code. Okay, so this is my VS Code. You can use Jupyter Notebook in the usual common Jupyter Notebook interface. There is no problem at all. You can use a Jupyter Lab instance. There is no problem at all. I just prefer using VS Code for personal reasons. I think it's a more flexible interface, and I like to work inside VS Code. If you want to use Jupyter Notebooks inside VS Code, you need two extensions. One of them is this Python one from Microsoft, and the other is this Jupyter one also from Microsoft. If you have these two extensions, you can use Jupyter Notebooks inside VS Code. Okay, but this is completely optional. You can use VS Code. You can use Jupyter Notebooks in the usual interface of the Jupyter Notebook program. Okay. So let's start showing how this package deals with chemical elements. So we can do here from Molmass import elements. Okay, and this is only a container of each element properties. Okay, we can see here elements, and as you can see, we have here each element of the periodic table: hydrogen, helium, lithium, and so on. Okay, the output is truncated since it's a long list of elements, but we can get each element as a dictionary key. Okay, this is not actually a dictionary. Okay, we can see here the type. So this is a type created by the developer of this package. Okay, so this is the type elements, but its behavior is dictionary like. Okay, so if I want only hydrogen, I can do the following. I can do here elements and search for the key hydrogen with its symbol, and I will get all the properties for this element. So this elements object behave like a dictionary. I can assign this to a variable. So I will create here a variable called hydrogen, and I'll have all the properties here. So we have here this class element, and we have here some properties of the hydrogen element. Okay, and we can think of these properties as attributes of a class. So for example, if I put here hydrogen dot protons, I will have the number of protons for the hydrogen element. Okay, and the same thing for any other property listed here. And what makes this package very interesting is how it deals with isotopes. So let's take a look here, hydrogen dot isotopes. So we have here the two isotopes, two hydrogen isotopes, and their abundances. Okay, so this is one thing that distinguishes this package from many others. It deals with isotopes. Let's create here another variable for another element. So let's get here the oxygen element. So here we have oxygen. Here we have also the isotopes from oxygen. Okay, and why I'm showing hydrogen and oxygen? Because now I'm going to show you how you can create a formula of a compound, of a molecule. So to create a formula, we have here from Molmass import formula. And this package has a very useful chemical formula parser. It will recognize most formulas in the usual way that we write them in chemistry classes and chemistry activities. So for example, if I want to create here the water molecule, I'll pass here its formula as a string, and I'll get here the formula H2O. Okay, and how I'm sure that the package recognizes this as a chemical formula, I can ask for the number of atoms with this attribute atoms. See here 3 atoms as expected for a water molecule formula. I can also make sure that this is a neutral molecule, asking for the property charge, and I see here that the charge is 0 as expected for a water molecule, a neutral molecule. Okay, and concerning mass, we have actually 3 possibilities. Okay, and I made a small text to explain these 3 possibilities. So we have the property mass, that's the average relative molecular mass considering the natural abundance of isotopes, equals to the molar mass in grams per mole. So probably this is what you think about when you ask about the molar mass of a molecule. This is the average relative molecular mass considering the natural abundance of isotopes. Okay, but you can also ask for the monoisotopic mass, and this is the mass of the molecule considering only the most abundant isotope of each element. Okay, so as we've shown here before, we have for hydrogen these 2 isotopes. This is the most abundant, and for oxygen we have these 3 isotopes, and this is the most abundant. So if you're asking for the monoisotopic isotopic mass, you have the mass of the molecule considering only the most abundant isotope of each element. Okay, and finally we have the nominal mass, the number of protons and neutrons in the isotope composed of the most abundant elemental isotopes. This is the mass number, as we usually learn in general chemistry classes. Okay, so let's take a look at each one of them. So water.mass, we have here the number that you will probably think about when you consider the molar mass of the water molecule. And now we have here water.monoisotopic mass. So this is slightly different from the previous value because this value takes into account only the most abundant isotope of each element. Okay, and now we have here water dot nominal mass, and we have here 18. Okay, again, what this nominal mass is the number of protons and neutrons considering only the most abundant elemental isotopes. Okay, so we have here this mass number for oxygen, 16, and we have here this mass number, 1 for hydrogen. But we have 2 hydrogen atoms, so this is 1 times 2 plus 16, and then we have this number 18 here. Okay, so this is how this package deals with mass. I think it's very interesting to take into account this isotopic distribution. And this is something that sometimes we don't think much about when we are making some calculations, but I think it's very important to remind this, and that's why I'm showing you this package. So these are some of the attributes, but this class also have some interesting methods. Okay, so let's take a look at them. We have here water.composition, and this is a method that will make some calculations to show you the composition of the molecule. But as you can see here, it has a string representation that's not complete. And what can you do to see all the composition? You can put this inside a print statement, and water.composition will show you a table-like result with the count of elements, the relative mass, and the mass fraction and percentage. Okay, this is one way of deal with this composition method, but you can also ask this as a data frame. That's why we saw in the beginning of the video that this package needs pandas, and now we can do water.composition.data frame. And here we have pandas data frame with the same values, but since pandas is widely used in Python programming, this is probably the way that you want the results to be displayed as a pandas data frame, because it will help you perform some integrations with other tools in Python. See, since this is a isotope centered package, we can pass some formulas with isotopes. So let's create here deuterated water. So I'll call this the water, and I'll pass the formula as D2O. Okay, since D is a usual symbol for deuterium. So now we have here the water, and see that the package recognize this as the hydrogen element with 2 here. Okay, so this package recognize most usual symbols for isotopes. So let's take a look here. The water.mass, you can see that this is different from the value that we've seen before. If the isotope doesn't have a special symbol, you can pass it with its mass, as seen here. Okay, so let's create here a CO2 molecule, but with carbon 13. So I'll call this carbon 13 CO2, and I'll pass the formula as string with 13C and then O2. Okay, so we have here carbon CO, carbon 13 CO2, and we can see here the carbon 13 isotope. Okay, so if the isotope doesn't have a special symbol, no problems at all. You can pass like this between brackets and with the mass number here. One thing really useful in this package is that it can perform mass distribution calculations. Okay, so you can simulate a mass spectrum. So let's create here a large molecule like chlorobenzene, for example. So chlorobenzene, and the formula is C6H5Cl. So we have 6 carbon atoms, 5 hydrogen atoms, and 1 chlorine atom. So let's make sure it understood chlorobenzene and chlorobenzene dot atoms, and okay, we have 12 atoms. Okay, let's take a look in the composition. Chlorobenzene dot composition dot data frame. Here we are. We have here the atom counts and the relative mass and the mass fractions, but we can also calculate its spectrum. Okay, so we can see here chlorobenzene dot spectrum dot data frame. And now we have here the mass number, the relative mass, the fraction, and the intensity, and the mass charge ratio for these peaks and the mass spectrum. We can see that we have some peaks with low values for intensity, so we can pass here a minimum intensity. So we can pass here for the spectrum method mean intensity argument with the value that we want to be the minimum. So I'll pass here 0.01. So now we have 5 peaks. This can be really useful if you are dealing with mass spectrum data. You can now simulate some of the peaks expected in this spectrum. I will assign this data frame to variable so it can be easier to deal with this data. So we have now a variable for this data frame. And since this is mass spectrum data, you can build a plot. So I'll import here matplotlib. I'll create a figure, an x, so pt dot subplots. And a mass spectrum is mainly vertical lines, so you can use the vlines method from matplotlib, and I'll use the data that is in the data frame. The x axis will be the mass charge ratio, and we have here the minimum value for y to be 0, and the max values will come from the intensity column. Okay, let's take a look. So we have here the simulated mass spectrum. So this is the highest peak, the peak with the maximum intensity. Okay, we have relative intensity, and we have here this other one that is also easy to see. You can prove this plot with the labels. You can prove this range here. In the link in the description below, you'll find a blog post where I show all the details of this package, and I'll show you how you can improve this plot. Okay, with the labels, a better scale here, you can do many more improvements in this plot using matplotlib. In this video, so it not take so long, I'll just show you this plot the way it is now, but you can improve it a lot. You can also parse ion formulas. So let's create here chlorobenzene ion, and I'll pass the formula with brackets. So we have here C6H5Cl, and I'll put outside of the brackets 2 plus. So now I have an ion here. So chlorobenzene ion. So we have here this ion, and we can make sure this is a ion asking for the charge. So we have here the charge equals 2. So that's how you can create an ion with this package. So this is it for this video. I just want to show you this package with some of its features. It does have many more features. You can see all the features of this package with examples in the link in the description below. It's a link from my site, chemistryprogramming.xyz. I write there some blog posts showing Python packages that you can use to perform chemical analysis. And in the blog post, I show you many more examples of what you can do with this Molmass package. And if you like this video, please click in the like button, subscribe to this channel, share it with your friends, and I see you in the next video.